So now we can see the results here of the dense optical flow, where we can see when we're moving around in the environment here, or like in the frame, we can see these arrows here representing like how much motion is there in the image frame. Hey guys, and welcome to a new video in this computer vision tutorial. So in this video here, we're going to talk about dense optical flow. So in the last video, we talked about sparse optical flow, where we just took different kind of points or like good features in our image, and then we were tracking around those points or objects around in the image frame. But now we're going to talk about dense optical flow, where we're going to look at the whole image plane, and we're going to see like how motion is actually like changing from frame to frame with our camera. But first of all, we're going to join the Discord server. I'll link to it down in the description here. You come join the channel, chat with us about computer vision, deep learning, AI, and so on. You can also become a member of the channel if you want to support the channel with a small monthly fee, and everything will go to create more and better quality content here on the channel. So thank you guys. So first of all here, we're going to start in the OpenCV documentation again, because this is actually like just one method or like one function that we're going to apply. And then we're actually like just going to draw or like plot what we actually like get as the output from this function here. So this function here, it computes a dense optical flow using the Gunnar-Fahrenbach algorithm. As we can see here, we can see all the different kind of input parameters it takes, how we can set it up in Python, and we can also see like the data types and stuff like that we need to pass into this function to be able to have it work. So here we can see that it takes an input array, two input array here, and it also takes like this output here, which is the actual flow. So this will be the flow, which will correspond to the change of motion in the image frames. So we need to pass in the previous image frame, and we need to pass in the next image frame to actually be able to see a change in motion from the previous frame to the next frame that we load in from a webcam or like any other camera that you're using. Then we need some other different kind of parameters that we need to set as well. We're just going to set them as default in this video here, but you can play around with them if you want to change some of them for your own applications, or you won't get like, you're not getting like that good results, you can play around with them as well. But down here in the description, we can read what these parameters actually like does. So we need to make sure that our images that we load into this function or like pass into this function is 8-bit single channel input images. So we need to, first of all, we need to convert our images to grayscale images before we pass them to this function, because it only works on 8-bit single channel input images. And then we're going to do the exact same thing for our next image. So we're going to pass in 2 images, and then we'll get back a flow, which we can see here, which is a computed flow image that has the same size as the previous and type. So we're going to have this 32-bit floating point data type here with 2 channels. And then we can actually like go in and draw this flow here. So we'll get the errors. So we can see how much is the motion, how much motion is actually like changing from one frame to the other. So here we have these different kind of parameters. You can just go in, read through them if you want to. We're just going to use them in this video here, but we can see we have this pure scale where we have this parameter specifying the image scale below 1 to build pyramids for each image. So we also talked about that in the previous videos, these pyramids, how they actually like find these optical flows. So we have a pure scale here of 0.5. It means that a classical pyramid here, where each next layer is twice smaller than the previous ones. We also have some levels, window sizes, so like the averaging window size we want to look at when we're actually like sliding through our image, and we want to capture that motion in our image, or like from the one frame to the other frame. We also have a number of iterations here that the algorithm does at each pyramid level. We have some poly-end, poly-sigma, and stuff like that. And we also have some optional flags down here that we can set if we want to use like initial flow or like Fahrenbach Gaussian. We can read what all of these things here does. We can even go in and find the algorithm, how to implement it. But in this video, we're just going to use some default parameters, use this method here, and see how we can actually like set it up in code. Again, you can download the code on my GitHub. I'll link to it down in the description here. You can just go into GitHub, take the code, copy paste it, run it on your own computer, and just play around with the parameters. You only need the Python script and just run it, and everything will work. So let's now jump into the code here and see how we can actually like set these things up and how we can use this function that I just showed you in the OpenCV documentation. So first of all, again, we're just importing our modules, NumPy, OpenCV, and time, so we can see how many frames per second do we actually like get when we're running this algorithm here and creating this dense optical flow, where we're looking at like how motion is changing in our images, or like how the environment is changing in our image frame. So first of all, here we're going to have a function, and we won't go into details with these functions. So we're going to have a function to draw the actual flow, where we just pass in the flow, and we know that we get back a 32-bit floating point number with 2 channels, which will correspond to the flow. So this will be the errors that we're actually going to draw and see when we're going to run the program at the end of the video. So here we're actually just going to draw the lines and the arrows, and then we're going to use these polylines as we did in the last video, where we're just tracking around objects, trying to be able to draw lines from our trajectories in the last video where we tracked around different kind of objects. We're going to do the same thing in this video here, but we're going to do it for the whole image instead of only for specific points. So basically the idea is the same here. We're just converting to the correct colors, and then we're just drawing these lines and the circles for these points that we actually detect, and we get from this flow function later on. So this is just how we can draw the flow. And also down here, we're going to draw the HSV. So we're going to draw a color image besides it, so we can actually see the whole image, or what is actually changing in the image from the one frame to the other frame. And then we're going to have another frame where we have these errors, so we can actually see how much, not even what is changing in the image frame, but how much is it changing in the image frame from the previous frames to the next frame. So we won't go into details with these. We just pass in the flow, we correct it to the correct color, and then we just convert it back and forth between HSV, BGR, and RGB. And up here we're drawing our actual errors on our image. So down here we're going to open up our webcam. So we have this cap here where we just open up our video capture at the 0th element. So this is my webcam. And then we're just going to read in the first frame here from the webcam before we're going into our while loop, because this will be our previous frame. So we first load in a frame, that will be the previous frame, and then we will load in a new one. So we have 2 frames, and then we can look at how the motion, or how the environment is actually changing from the previous frame to the next frame. And that is those 2 frames that we pass into our function. We'll get the output, which is the flow, and then we just draw the flow with the functions that I just showed you up above. So here we're just going to convert our colors first of all from BGR to grayscale, because we know that we only need it can only take 8-bit single channel images. So it's grayscale images where we have values between 0 and 255 for the pixel intensities. So down here we're just going into a while loop. So while true here, we're just going to run a program until we hit Q, and if we hit Q at any time in this while loop here, we'll just terminate the program, release our webcam, and we will restore all the windows that we have opened up with OpenCV. So now we're going to read in the new images, and then later on we're actually going to, when we read in this image, we're going to set that equal to the previous frame later on. But now we're going to read in a new image, and then we're going to convert that to grayscale as well. And then we're just going to start a timer, so we can actually time how long does this algorithm actually take to run, so we can see the number of frames per second that we get by creating this dense optical flow and tracking around everything that is moving in the image frame. So down here, we're just going to use this function that I showed you in the documentation and what this video is all about. So we have a flow here, which is equal to cv2.calc optical flow with this far and back algorithm. We just pass in the previous frame, the new frame, and then we have these parameters here, which is the default. You can go into the documentation as I just showed you. So these are just the parameters that you can set, play around with them. We had this 0.5 here, which they just showed you, showed as the default in the documentation. We also have the window sizes and so on that we want to look at. Play around with these parameters if you want to change it for your own application or project, but this works in most cases or in general, because these are just default parameters. And then when we're done that, we actually have the whole here. So we have a whole flow. So we have the whole dense optical flow actually stored in this variable. Then we can just set our new frame equal to the previous gray frame. So we just keep updating every time we have calculated our flow. We will then update our previous frame to the frame that we just calculated the flow for. So we just keep updating it. So we get the newest frame, and then that frame will be the previous frame. So we're looking frame by frame how the motion is actually changing from those frames. So we're going to end the timer here. We're just going to calculate the number of frames per second. So it's just 1 divided by the end time, subtracted by the start time. We're just going to print out the number of frames per second so we can see how fast it runs. Then we're just going to call this imshow. So we're going to show the flow here, the actual flow where we can see the errors. And then we're just going to use this draw flow function where we just pass in our grayscale image. So the image where we want to actually draw our image. And then the flow here that we want to draw on top of that image. So this will be the errors and the polylines as we specified up in that function from OpenCV. Then we also have this flow HSV here. So we actually have an image where everything is black if there's no motion tracked or detected in the image from one frame to the other. And if there's actually like some differences, we're going to look at like in what direction is that motion, and then it will have a corresponding color regarding or like for that direction of motion, and also how much it is actually like changing in the image frame. So if we hit Q here, we will terminate, we will just break, we'll terminate, release our webcam, and destroy all the windows. So everything we had to do is actually like just have these functions that is drawing what we wanted to on the actual images, so we can see what is going on. So these will be the errors, and down here we're just going to have this HSV, so we can see like how the motion is actually like changing from one frame to the other. And we're also going to have HSV colors for the directions of our optical flow. So this is everything we need, and then we just call this function from OpenCV. It will run the whole algorithm, and it will create this dense optical flow that we can then use. So this is everything, and we can now run the program and see the results. So down here, it will just load in everything. We can see we get around like 30, 40 FPS, and then we get the images up here at the bottom. So over here to the left, we can see the image with the dots here, and then if it tracks some motion in the image frame, we can actually like see we will get these errors, and depending on how much we're changing from one frame to the other frame, the magnitude of our errors is actually like changing too. So we can see here, if I'm starting to move faster, the errors will actually like become bigger or have a greater magnitude. So we can see the faster you're moving, the greater the magnitude of the errors, and if there's only like small changes, we can see the errors is also smaller. And we can also see the direction of the errors here, which will correspond to the direction that the motion is actually like detected, or like the optical flow is detected in the image frame. And it will do this for all the pixels in our actual like image frame. So this is what dense optical flow is. In the last video, we just tracked different kind of corners in our image frame, and then we will act like tracking those corners around, storing the values, and then we didn't do anything else with that. But in this video here, we have this dense optical flow, so we can track motion in the whole image at the same time. And over here to the right, we have this flow HSV. So we can see here, if there's no motion in the image, everything is just black. We can only see my mouth here now is moving. So if I'm moving to the right here in the real world, we can see that the color actually like changes to red. And then when I go into the other direction, it actually like changes to blue. So we go red, we go blue, and then if we go up, we start to get green. And if we go down, we get like purple or blue, or like darker blue. So we can actually like see that these colors here alter the text in what direction are we actually like moving from one frame to the other. So if you're moving around here, we can see like all the different kind of things. How is it moving? In what direction is it moving? How fast is it moving? So we can see that the color is actually like brighter the faster we move as well. So that will correspond to the magnitudes of our errors in the left image. So this is actually really nice and really cool, and we can use it for a lot of different kind of things. As I said in the last video, where we talked about like if we're, for example, having camera on top of like a highway and we want to track cars around, or in the case here with dense optical flow, if you, for example, had some fluid or like some objects moving around in the image frame, and you want to have the whole image frame, and you want to detect motion in the whole image frame, but not only motion, but also how much, or like the magnitude of the motion changing from one frame to the other frame. So it can be used for a lot of different kind of useful real life applications. So I just think that this is really nice, and it's actually really cool. And we're definitely going to create more videos on the channel here and create some projects where we're actually like using these different kind of things for some really nice projects, because again, these are just two functions to actually like draw these things, and then we just call one method or like one function from OpenCV that does everything for us. We just need to pass in two images, and then we get the flow out here by running this algorithm where we get up to like 30, 40 frames per second on a standard CPU. We are maybe also going to do it here on the GPU in the CUDA OpenCV tutorial, where we're using the GPU to speed up some of the processes here, because that is way more efficient. So thank you guys for watching this video here, and remember to hit the subscribe button and notification under the video, and also like this video here if you like the content and you want more in the future. I'm currently doing this computer vision tutorial where we're talking about like basic image operations, how we can calibrate cameras, use stereo vision to estimate depth in images. Now we're starting to talk about like point clouds, how we can use point clouds in computer vision, and also optical flow. So now we're talking more about real life applications, how we can see motion in images, but also 3D information about like in our environment, how we can get that from only using cameras and stuff like that. So I'll link to that tutorial up here, or else I'll just see you next video, guys. Bye for now.